So yes, class. In the last class, we had started with magnetic Lorentz force. So Q V cross V, the introductory part of this we had covered already. Q V cross V. Now that didn't end it. That was actually the beginning of the class of it. Beginning of magnetic Lorentz force. So here you have to remember this formula Q V cross V, where V is the velocity, B is the magnetic field, Q is the charge. Magnetic Lorentz force in case of electric field also we'll see electric field, but if only magnetic field is given, then this formula is sufficient. Now then we had seen the theoretical question which can come if force is perpendicular to velocity. So if force is perpendicular to velocity, then force is perpendicular to displacement. So kinetic, there won't be any change in work done, there won't be change in kinetic energy, and there won't be any change in the velocity. Till here we had done. Now, coming to the right-hand thumb rule that was left in the last class. So, see class, from this lesson, no, this is one of the major topics that is left. One of the major topics, one of the lengthy topics we can say. Fine. So, in this case, what we have to do, we have to find out the direction of this magnetic force. What all directions we have studied till now? If we summarize all those directions, for the circular one, we had seen initially, let's start from the beginning. There were two methods which we had started with. If one method was just place your thumb in the direction of current, curvature gives the direction of the magnetic field. Second was place your fingers in the direction of current, curl your fingers towards the point, thumb gives the direction of magnetic field. If your point is located towards here, this way I'll curl it. So this will be the direction of magnetic field. So these were the direction of magnetic field. For circular one, we had seen you have to move your hand along the sense of current. Along the sense of current means if the current is flowing clockwise. So curl your fingers clockwise. Thumb gives you direction of current. If your current is moving in the YZ plane, so curl your fingers like this. Thumb gives the direction. In this way, this also we had seen. Now comes force. So force we didn't discuss. So force also has a certain direction that has to be discussed. So that also we'll do with the help of right hand only. As I've told you, right hand thumb rule only we are going to use. We are only going to use our right hand so that you don't get confused with all the properties of the left hand rule. So this says basically wherever is the direction of the charge, for example, let's say this is plus Q charge, this is moving in a random direction. This is the velocity. So you have to place your fingers in the direction of velocity. So see, both these are parallel. Are you able to notice this? My hand and the velocity. So I have kept it in front of it. Obviously, for you people, it will appear parallel. So keep your hand firstly in the direction of velocity. Now you have to curl towards the magnetic field. I could also keep it like this. I didn't keep it like this because I know I have to, my magnetic field is where I have to curl it towards the magnetic field. So if I keep it like this, I'm not able to curl it towards the magnetic field. Magnetic field lines are these. These lines are magnetic field lines. So I'm not able to curl it towards the magnetic field. When I'm keeping like this, still not I'm able to curl it. See? Magnetic field is towards the right. How will I curl it like this? But if I keep my hand like this, now if I curl, see now my fingers are getting curled towards the right hand side. So this way, if I keep my hand, then I curl my fingers towards magnetic field, force is pointing like this. Fine. So the thumb gives the direction of force, wherever it is. So here, this was the direction. So force got into the page. So direction of force was inwards. Similarly, let's take some random other direction. Let's say this. This is charge moving with V velocity. So I have kept my palm firstly in the direction of velocity. Now, if I listen this carefully, this is very important because you have 4 cases out of which the third case is very important. First, second case you people will be able to do, and that's what is included in this magnetic Lorentz force. So I've kept my fingers in the direction of velocity. Now the magnetic field is still towards the right. How can I curl it towards the right? I have to curl it towards the right. So if I keep my hand like this, let's start from here. Am I able to curl it? I'm not able to curl it. If I keep my hand like this, then my hand is not in the direction of velocity. I have to keep it like this. If I keep it like this, if my hand is like this, or let me make it simpler. Let me make this in the direction.
And it should be pointing to a magnetic field. That the fingers should point to magnetic field, right?
No, your fingers should be in the direction of velocity, wherever is the direction of velocity. For example, that's what I'm saying. Let me draw it in some other direction. See, random direction I have found. Now, Fahad, see here. I have to keep my fingers along the direction of velocity. So if velocity is like this, so I can keep my hand like this, like this, like this, or like this. Only these four positions are possible. Now, out of all these four positions, which one I have to decide, which one I have to choose is decided by the direction of magnetic field. If I keep it like this, I'm not able to curl my fingers towards the magnetic field. If I keep my hand like this, I'm not able to curl it towards the magnetic field. If I keep my hand like this, I'm not able to curl it towards the magnetic field. So ultimately, what is left? This way, curling inwards. So similarly to this one is also moving inwards. This is the direction. Don't worry about the direction. Just understand the rule first. We have the direction in detail. So it's written also over here. Place your fingers along the velocity. Curl your fingers towards magnetic field. Direction of thumb gives you the direction of magnetic force. Fine. So this is the rule. But before going into the application of this rule, let's see few things. There are 4 cases regarding the path of charge in uniform magnetic field, and this is very important, and this part is easy. Out of which, C class, just understand what are we going to study right now. Path of a charge if a uniform magnetic field is there. So there we are going to see 4 cases, and all those 4 cases are very important, out of which first and second cases are very easy. That we can tell, and you all know already. First, second cases both are very easy. Third case is the most important case. From there numericals come a lot. Most of the numericals come from that portion, the third case. And the last case is a theoretical case. So last 2 cases are important from examination point of view. First 2 cases you people already know. How? See, QV cross B you know, which means QVB sine theta. This equation you are already aware of. So first case is if the charge is moving parallel to magnetic field. This means this is the magnetic field. Fine class, this is the magnetic field. Charge is also moving in this direction. Charge is also moving in this direction. That is the parallel direction. So what's the angle now that is formed between the magnetic field and the velocity? 0 degree, and sine 0 is 0. So magnetic force comes out to be 0. So it shows that path will not change. Since there is no magnetic force to change the direction of any of it, what happens? Charge is moving. Charge will keep on moving. It will not change its direction if it is moving parallel. Reason? Sine 0 is 0. Angle between V and B is what? 0. So if magnetic force came out to be 0, need not change the direction. Second case is also easy, as I've told you. First case done, clear, parallel, 0 degree, force 0. Path does not change. Second case, anti-parallel. So what's the angle that is formed? 180 degree. See, sine 180 degree is also 0. So this means what? This basically means this is the magnetic field line. Charge is moving exactly making an angle of 180 degree. So this is velocity. Now velocity and magnetic field, all these are forming what? Both of these are forming angle of 180 degree. So here also force came out to be 0. So out of the 4 cases, first two clear, parallel force 0, anti-parallel force again 0. Fine. Now we'll move on to the third case, which is very, very important. But before that, I want you people to at least write till here. We'll discuss this third case. This is very important if it is perpendicular. If the particle is moving perpendicular to magnetic field. Because this is important, so I want you, all of you, to pay attention. So note it down till here. Because now right hand thumb rule will get involved. Last case is easier, but third case is very important. These points are for, yes, magnetic force. Yes, magnetic Lorentz force. Now, third case. So, first and second cases are clear. Now, if the particle is perpendicular to the magnetic field, let's say this is the magnetic field. Magnetic field lines are pointing inwards into the page. Now, the charged particle, let's say the charged particle is over here. Fine, this is a charged particle. This charged particle is moving downwards with v velocity. So this part I'm telling, rest of the things I'll ask you certain questions from this. So please listen to this part carefully. What is the law? What is the rule? Law says the right hand thumb rule basically says what? You have to place your fingers in the direction of velocity. So downwards is the velocity, in this way, in this way, in this way, in this way, in any way I can keep. Now, out of these, which pathway to choose is that I have to curl my fingers towards the magnetic field. So magnetic field is inwards into the page. Where is my thumb going? Rightwards. So it means magnetic Lorentz force. Magnetic force is acting in which direction? Magnetic force is acting towards the right. Any doubts in this part? This is clear to all of you? All right, then in the chat box, reply me. Each one of you should reply. This charge is moving in this direction with v velocity. Now try. All of you should respond in the chat box. If you've understood this first part, how to apply the direction, then answer. What is the direction of force? Up, down, right, left. In terms of I cap, J cap, you can answer. Sahal is right. Fahad, check your answer again. Apart from Fahad and Sahal, Abia, right? Madiha answer. Samia correct. Rifat answer. Wafia. See, keeping my hand towards the direction of velocity and curling my fingers towards the magnetic field. Thumb is where? Thumb is not going outwards, Fahad. Thumb is going upwards. Outward is this, out of the page. This is upwards. So direction of force is what? Direction of force is upwards. Hand towards the velocity, curling the fingers towards the magnetic field, force upwards. Now, all of you answer this part. Sahal is right. Madiha, no. Correct, Samia. No, Fahad. See, Fahad, Madiha. Yes, Madiha. Now you're right, Madiha. Fahad, any corrections? See, outwards is what? Outwards is when your thumb is going like this. Thumb is pointing towards me. This is outwards. This is inwards. This is upwards. This is downwards. This is leftwards. This is rightwards. These are the directions. If I'm keeping my hand along the direction of velocity and magnetic field lines are where? Fahad, try this right now only. You keep your hand to right hand. I hope you're using your right hand, Fahad, because you're a lefty. Just keep in mind, right now you have to use your right hand. Right hand will only help you for this law. Abia upwards. Nahin. See, if I keep my hand towards the velocity like this, magnetic field is where? It's inwards. So I have to curl my fingers inwards. Where is the thumb leading? Leftwards, minus I cap, this direction. One last part I'm giving. Each one of you should be able to answer at least this. Otherwise, I'll start calling out names and ask you. Now tell me direction of force. All of you reply me in the chat box. I think by now, Zaid also must have understood what we were studying. So 2 students have answered, Madiha, Sahal, Samia, Wafia. Answers. Rifat correct, Zaid correct. Okay, Abia has answered. Fahad, your answer? Who's left? Has Sahal answered? Sahal has answered. So only your answer is left, Fahad. Everyone has tried. Out of these, Zaid, Rifat, Wafia, Samia, Sahal, you people are correct. Fahad, Abia, and Madiha, you people are making the same mistakes. Did you keep your hand along the direction of velocity? Okay, Fahad, just unmute yourself. And tell me, Fahad, how did you keep your... Not upwards, not upwards. See, Fahad, unmute yourself. See, I'm helping you. I'm helping you with it. Just unmute yourself and try to do along with me.
Yes, ma'am.
Fahad, now keep your right hand along the direction of velocity. Where are your nails pointing? Towards the right or left?
Left side.
Towards the right. Are you keeping your hand like this? Or
I'm
you're
keeping it straight.
like this?
Yes.
So if you are keeping your hand like this, where is the magnetic field? Inwards or outwards?
Inwards.
Now, Madhya, it's correct. Magnetic field is inwards. So will you be able to curl it like this?
No.
Then tell me, is this position fine? Will I be able to curl it inwards? Do it along with me, wherever
Yes,
you
ma'am.
are at. Fine. Now, if I keep my hand like this, will I be able to curl it inwards? Do it.
Yes.
Where is your thumb pointing?
Downwards.
Downwards. Now got it?
Yes, ma'am.
All right, good. So it will be downwards. Anyone else has doubt? Abia, clear to you? Clear? Fine. So this was important. Why? Now see. So now understanding of direction, I hope you people will be able to do. Most of you have done it correctly. Those who were wrong, now they have hopefully understood it. Now see. Now coming back to the theory part. So direction, all of you are clear with the direction. Huh? Now, are you able to notice one thing? In all the directions, the force is pointing where? The force is pointing towards the center. All these charges were moving, the force was pointing towards the center. See, I took 4 different positions. First, second, third, fourth. If I take all the position with which the charge must have covered, first, then slight movement of charge, slight movement of charge. If I take, are you able to notice this? This would have been the pathway of the charge. A circular pathway. Now see. If magnetic field lines are there and the charge is moving perpendicular to the magnetic field, motion of the charge will be what? Motion of the charge will be a complete circle. How? See, this was the first point that we took. Remember, this was the second point that we took. This was the third. You keep on taking any of the points. It will ultimately form a circle. And what will be the direction of velocity? Direction of velocity will be tangent to it. Yes, this was it, what we had studied. Right now, we had completed this part only. Regarding the force, every force was pointing towards the center. Each of these forces, every force was pointing towards the center. Can any of you name a force that acts along the radius and points towards the center? Acts towards the center and is along the radius. From your class 11th knowledge. Anyone?
Centripetal force.
Yes. Who answered? Madiha? Correct. Right. Centripetal force. So this basically force, no. Okay, one more thing. Are you people aware of centripetal force or not? See class, centripetal force is actually not a force. Remember in EMF when we did, what was the full form of EMF in current electricity? All of us have covered current electricity. EMF was what? Electromotive force. Was it a force or was it a voltage? We didn't see any property similar to force. It was a misnomer. Electromotive force was written, but every time we used it in place of voltage. Similarly, centripetal force, centrifugal forces, these are not actual physical forces that you study. And these do not have the exact property of all the forces. Centripetal forces are provided by other forces. They are like demands. There are certain demands, there are certain criteria. And to fulfill those criteria, other force fulfill it. So that's why understanding of centripetal forces and everything in class 11th is important when you do circular motion, uniform circular motion. So here also, magnetic force is acting towards the center along the radius, but it is fulfilling the demand of which force? Centripetal force. So the appropriate amount of centripetal force is provided by the magnetic Lorentz force. Fine class. Centripetal force is not a proper force. It is not an actual force. All of you must have studied in class 11 for those who are not aware of this fact. Or if you're having any doubts in this, ask me. I'll repeat the topic of class 11 if you have missed it or whatever. Centripetal force is not actually a physical force like gravitational force, tension and all these. If a tension is there, tension along a string, if I have a string and I curl it like this into a vertical circle, then that force tension will act towards the center. So that will provide me the centripetal force. Similarly, sometimes frictional force also provides the right amount of centripetal force. You must have seen those cases, bending of cyclist. All these are included in were included in your class 11th last year. All of you must have done that. Similarly, here also all the forces are acting towards the center, along the radius towards the center. That is the criteria of centripetal force. So here centripetal force has been fulfilled. So Madiha, do you remember the formula also for centripetal force by any chance? Do you remember it, or anyone else? Centripetal force. No one? mv square by r. Yes, Fahad. Centripetal force is acting in middle. Not in middle, you can say. You can remember these 2 points. These 2 points are sufficient for centripetal force or even centripetal acceleration. Anything that is acting towards the center, it is pointing towards the center and along the radius. Fine? So towards the center, along the radius. If anyone wants to write, you can even write it in your notes. Towards the center, along the radius. This is the criteria of centripetal force. And these questions can, regarding the centripetal force, it can get related to your Coulomb's law as well. Once this chapter is almost towards the end, after 2 to 3 classes, or 4 classes, we'll start with EMI. Once we'll do a brush up of chapter number 5th. EMI, AC, EM waves, these won't take so much time. These are very, very short lessons that we'll do. So once they are over, whole revision of your first book will start. More tests will be conducted. So you will have to revise all those things. So that time also we'll discuss it. Coulomb's law can also be related. If Coulomb's law is providing sufficient, Coulomb's law means basically electric force. If electrostatic force is providing the sufficient centripetal force, so we can equate Q1, Q2 divided by R square with the formula mv square by R. So yes, Fahad, it's not exactly in the middle. You can say towards the center along the radius. And what was the magnetic force that we studied? QVB. So both these forces are equal. Basically, magnetic force provided centripetal force. So mv square divided by r is equal to qvb. Understand class, this third case is a very long case. That's why I was focusing on this. We'll do numerical also from this. A question also. One type of question comes a lot. Even this question, I think, came in this year's NEET paper also. In entrances also it comes. So VV got cancelled. Radius of that circle that has been formed, that path of the charge enclosed a circle, and the radius of that circle is mv divided by qv. Fine. Now, certain other quantities are also asked. What is time period? Time is what? Distance divided by speed. So, what's the distance for this charge? Can anyone tell? What's this? What's the distance that will be covered by, let's say, this charge, which is forming this complete circle? Distance of this circle. How do you calculate the distance covered in a circular path?
With
Circumference, and it is 2 pi r. Yes, Samya, it's 2 pi r. So it will be 2 pi r. Distance is 2 pi r. Speed, you can calculate it from here. Speed, you can write speed from here. So distance is 2 pi r divided by the speed. Let's put the formula of radius. So this becomes 2 pi r. This is mv divided by v into qb. So from here, velocity gets cancelled. Time period's formula is 2 pi m divided by qb. All these formula are not just for the derivation purpose. You have to remember these formula. This comes in this time period. If you look at the previous years, this time period question has been asked so many times, and especially this fact whether time period depends on velocity or radius. So while looking at the formula, you can say it is independent of the radius and velocity. It depends on the magnetic field, charge, mass, whatever. Frequency is 1 by time period, reciprocal of time period. So this frequency becomes qb divided by 2 pi m. And omega also. Omega is basically 2 pi divided by t. This relation omega is equal to 2 pi t, which you have studied in your rotational dynamics in class 11th. This relation will be used in alternating current as well. So do not forget this. Omega is equal to 2 pi by t. This is a simple formula. This will get used a lot. Now, if omega is 2 pi by t, so omega becomes 2 pi divided by t. T is 2 pi m by qb. 2 pi gets cancelled. Omega comes out to be qb divided by m. Now a fixed type of question comes from here. If it will do what? It will provide you certain types of charges: electron, proton, deuteron, alpha particle, helium particle, like this, whose charge and mass you are aware of. Fine, those easy particles. And the question will ask you to compare the time periods, find out the ratio of time period if masses are same, magnetic field is same, any condition it can give you. So those type of question we'll see. We have a big question from that topic, but first note down here, then we'll discuss that. So this is the third case. If particle is perpendicular to magnetic field, there will be a change. Here magnetic force is not zero. There will be a change over here. That is, the path of the charge will be in circular form. First case, 0, no force. Second case, 180, no force. Third case, 90 degree, yes, a circular pathway. Clear to all of you, yes or no? Yes, class, any doubts? Abia, Sahal, Fahad, Bafia.
And that cross is the magnetic field, right?
Yes, cross is magnetic field, which is showing that magnetic field is inwards. This is the magnetic field, which is showing it is inwards, just a direction. Wafia, is it clear to you?
Yes.
And Rifat, did you understand? Time period. So T is the time period. 2 pi r divided by V. Distance divided by speed.
Ma'am, and that R is the radius of centripetal force, right?
R is the radius of the circle that has been formed or that has been enclosed by the pathway of the charge.
Magnetic force number, yeah.
Yes, yes. So when this charge goes, no, because of the tangent velocity, velocity is tangent and magnetic field is inwards. Or even if magnetic field is outwards, if you have any of these cases, magnetic field and velocity are perpendicular to each other. So what you will see that charge will all the points, if you join all the points, now you'll see a whole complete circle is formed. And the radius of that circle is R. And time period is the time covered by the charge to form that complete circle. So omega, this W is omega, which is angular velocity. This new symbol is frequency, linear frequency. See here, what is the question saying? A proton, deuteron, and an alpha particle, all these enter in a uniform magnetic field which is perpendicular. You have to find out the ratio of the first radius. Just find out the ratio of radius. Leave time period frequency. If you find out the ratio of radius, you'll be able to do time period and frequency. Just find out the ratio of radius. If they're having same velocity, second part same momentum, third part same kinetic energy, fourth part same potential. This is a very important question. All of you must mark all those asterisk signs and stars for this question. This type of question. These type of questions do come in the exam. Now, this portion that I've written in yellow portion that I've written, this is the relation. If mass of proton is mp, then deuteron has the twice of mass of a proton and the alpha particle has 4 times the mass of the proton. Charge on proton deuteron remains the same, and alpha particle, it is twice the charge. So this becomes 2e, not just 2 times e. This is the, now one more thing class, this portion that I've written in yellow color, this I have written, this is not a part of question. So you have to remember these points, that if mass of proton, and what's the relation between mass of proton and alpha particle and all these, you have to remember these points. This won't be mentioned to you in the exam. What's the relation between deuteron, proton and all these? This I have written for you people. Means it is not a part of question. So that's why I'm saying. Let's do the first part first. Same velocity. Formula of radius from here. mv divided by qb. Now we just have to modify this only. First part says radius is what? mv divided by qb. Fine class. Magnetic field will remain the same. First part says velocity same. First part has given to you the condition. That's the question, that velocity is same. So velocity is same and magnetic field will obviously be same because all the charges are moving in the same magnetic field. M and Q will be different. So we have to find out radius of proton is to ratio of radius of deuteron is to ratio of radius of alpha particle. This becomes mass of proton by charge on proton, velocity and magnetic field are same. Mass on deuteron, velocity is the same, charge on deuteron, magnetic field. Mass of alpha particle, velocity, charge on the alpha particle, magnetic field. From here, velocity and magnetic field will get cancelled. Now let's write everything in terms of proton. So this becomes mp by E. Mass of deuteron, twice of mass of proton. Charge on deuteron, exactly the same, is 2. Mass of alpha particle, 4 times the mass of proton. Charge on alpha particle, 2 times the electron. E got cancelled, MP got cancelled. 2, 1, 2, 2 times 4. RP is to RD is to R alpha, comes out to be 1 is to 2 is to 2. First tell me, first part clear to all of you? Okay, Zaid, you come. Other students clear? This is the method we have to do. It's just that we have to keep on doing the modification. If anyone is facing any difficulty, ask me right now. Fine, because as I've told you, this is one of the important questions. Fine. And these type of questions definitely you people should see before you appear for the exam. Second part says same momentum. Did we see any formula where momentum came? No, we didn't see any formula where momentum came. What's the formula of momentum?
MV.
MV. Only Madiha has studied class 11th. MV. Momentum is MV. Mass into momentum is basically the product of mass and velocity. Fine, it is MV. Now, formula of radius, it is MV divided by QB. So, can I write this term as P divided by QB? Momentum divided by QB. MV is already given. Now, P is also the same. This is also same. Magnetic field is also same. Only charge is different. So RP is to RD is to R alpha will be what? This will be 1 by, see P and B will also get cancelled. 1 by charge of proton is to 1 by charge on the deuteron is to 1 by charge on the alpha particle. This becomes what? 1 by E is to 1 by E is to 1 by 2. 2E. So E also gets cancelled. Ratio comes out to be RP is to RD is to R alpha comes out to be 1 is to half. You can write 1 is to 0.5. You can multiply everything by 2 and write 2 is to 1. That subjective questions, leave these things up to you. However you want to submit your answers. If it was an MCQ question, then options would have been provided. Ma'am, why are we not writing P in the numerator? See, even if you write P in the numerator and B in the denominator, this was left. Yes, Fahad? So P gets
Okay,
cancelled.
it can get cancelled.
Magnetic. Yes. Clear?
Yes, sir.
Okay. Third part says same kinetic energy. Again, we have to modify our answers. We have to find out same kinetic energy. Kinetic energy. Apart from Madhya, can anyone now tell me the formula of kinetic energy? This is the easiest question.
Half mv square.
Half mv square. Thank you, Fahad. See, this will be half mv square. Now, half mv square is same. We do not have half mv square anywhere. So, what will be velocity from here? Velocity will be 2 times kinetic energy divided by mass under root. And formula of radius is mv divided by qb. See, what I'm trying to tell you is that you can get anything, same kinetic energy, same potential, same mass, same magnetic field, anything can be given to you. Method remains the same. Method of calculation or how to solve your answers, that remains the same. So with the help of that only we are going to solve. We don't know, we still don't know how to put kinetic energy. So we can have formula of, we can put velocity in terms of kinetic energy. At least we'll have kinetic energy in our formula. So if you put this becomes m by qb under root 2 ke divided by m. Fine. So even if you want this is root m, no? So root m can come in the denominator. This root m and this m can get cancelled. This becomes 2 kinetic energy mass divided by charge into magnetic field. See class, these new formula that are coming, these are just modification. So those students who can remember this, try to remember it. Just learn it, these formula. Because in the exam, only these kinds of question come. So if it comes, it will save a lot of time. If you are not able to remember it, no worries. At least you should remember mv by qb,
Ma'am,
half mv
can't
square.
we just substitute that normal formula?
Which
Half
normal
mv
formula?
square.
Where?
Half mv square.
Where we cannot substitute it?
Like in the radii.
In the radii only we are substituting. See, here you have half mv square. Now to make this as half mv, earlier what happened? Earlier momentum was given. So here what happened? We just found mv here. So we didn't need to change anything. So we just put it like that. Now what is happening? If I want half mv square over here, so I have to multiply half mv is here to make it v square. I have to multiply and divide it by v. Then to make the denominator 2, I have to multiply and divide it by 2. From here, this is half mv square. But what is left? Ke twice qbv. Now this is left. But we have no idea of velocity right now. No knowledge of velocity is given. How will we do it? In the first part, it was specified that velocity is same. So we could directly use it. In the second part, velocity got eliminated in the formula of momentum. Similarly, we want such a case where we get rid of velocity. We are only aware of the fact that magnetic field is same. And that too is not given directly. That we know because all the charges are in same magnetic field. Got it, Fahad? This was what you were asking?
Yes, ma'am.
All right. Otherwise, it's better if you people try to find out the formula in the radius, the way Fahad is mentioning right now. But yes, if it is not possible, then definitely you have to do substitution method only, the way we have done it. Because velocity will be additional. Now from here you can solve this. Rp is to Rd is to R alpha. Now I'm not writing everything. This much you people can do. See, 2 kinetic energy mass divided by qb. From here, this kinetic energy is same, magnetic field is same. Charge. 2 will get cancelled. Mass of deuteron divided by charge of deuteron into magnetic field is 2 times the kinetic energy, mass of alpha particle divided by charge of alpha particle, magnetic field. So from here, root 2 into root kinetic energy divided by magnetic field will get cancelled. You will be left with under root mp by e is to under root 2 mp by e is to what is here? Under root 4 mp divided by 2e, where masses I have substituted, whatever is the relation between the masses of all these three. So E gets cancelled, root get cancelled. 1 is to root 2 is to 1. Because this will be 2 divided by 2 will give you 1. So Rp is to Rd is to R alpha. This is the answer for the third part. Now last part says same potential. For same potential. C class, kinetic energy. This relation, we are going to do it in this year only. Means in your 12th standard, this is included in your second term when we'll do modern physics, dual nature of atoms, that is included. But class, you people have studied this relation in chemistry. It was included in your chemistry. Are you people aware of the fact kinetic energy is charge multiplied by potential? You must have done it in your structure of atom in class 11th. Charge multiplied by stopping potential. Is it still included or has it been deleted? Anyone has an idea of this? Zed, I think, must have been having idea because it was there in ICSE. Anyways, whatever. Kinetic energy is charge multiplied by the potential. Now, potential, stopping potential, cutoff potential, that things we'll do in photoelectric effect. You people must have heard of photoelectric effect at least. So kinetic energy is charge multiplied by potential. Now, this time we have no information of kinetic energy. We just have information of potential. So in the formula, R is equal to QB. This that we got under root 2 kinetic energy mass divided by QB. Put the value of kinetic energy as E into the charge. So this comes out to be 2 EV M divided by, not E exactly, this is for an electron, Q. QVM divided by QB. Fine class? Yes. So from here, potential is same, magnetic field is same, root 2 will get cancelled. Rp is to Rd is to R alpha. So root 2 will get cancelled. Charge, what is left? Charge of the proton, mass of proton divided by charge of proton is 2. See, magnetic field, potential, root 2 will get cancelled. Understanding? Is 2. Then charge on deuteron is same. Mass of deuteron is twice the mass of proton. Charge on deuteron is same. Under root. Twice is the electronic charge of the alpha particle. It's a helium particle basically. 4 times the mass of proton and twice the electronic charge. So C, some things get cancelled over here. From here, Rp is to Rd is to R alpha comes out to be, this whole term will get cancelled 1. From here, root 2 is left. From here, what is left? EMP gets cancelled. So that becomes root 8. Root 8 is 2 root 2. So 2 root 2 divided by 2 gives root 2. This comes out to be 2. Fine class, I've solved all the 4 parts. Start noting down these parts. Wherever you're not able to understand, ask me. I made that announcement in the last class that we will be having a test of Biot-Savart's law on 22nd. I told you, no, 23rd. I told you, Tuesday. Fine. So class, just one thing. On that day, no, after the proper class, I'll be having the test. Means in the 1.5 hours duration, it is not possible to take the test also, because in 45 minutes or 1 hour class, very few portion of the syllabus will be covered. At least if you're over with this lesson, no, a major portion of your first book will be over. So the class will be till 11 o'clock. 11 o'clock means my 11 o'clock is what for you people? 7 o'clock. Your class starts from 6:30, no? So it will be till 8:30. 8:30. Okay, Samia, yes. Till 8:30. And Zaid, you are in India only, no? So students who are in India, for you people, give the test between 10:30 to 11. Okay, Zaid. So Zaid, I hope 11 o'clock is not very late for you. On not 22nd. 22nd is Monday, I believe. You people do not have class on 22nd. Let me see. 22nd is Monday. You have class on 23rd, so 23rd. 23rd, that is Tuesday. Not today. Tuesday. Have this weekend, prepare it. That's why I announced it on 16th. So that you people get a 1 week gap. Though a very short portion is also coming, half an hour is sufficient. 20 minutes are also sufficient for it. But the test, please do not miss the test. These tests are very important. These tests are also easy. I'll also show you your papers. If anyone, I think I have sent you your marks, no? So some of the students have done very well. Most of you have done the derivation part well only. I'll show you the papers if you wish. But just prepare that portion, Biot-Savart's law. That law, the applications of that law. Not only the formula BDL, IDL, sine theta divided by that. Apart from it, all the cases that we have studied till that last case, no, for semicircular arc, no, for a circular arc, till that. Not only till that, center of the axis of the circular coil, till that. Before Ampere circuital law. Ampere circuital law I'm not including in this test. So 1.5 hours regular class we'll have. After that we'll have the test, because you people have 1.5 hours class. Other batches have 2 hours class, so test is possible. Otherwise your portion will be left. Someone was speaking something. Fahad, were you saying something?
Ma'am, the applications of magnetic field, right? For the test.
Applications of magnetic. That is not actually applications of magnetic field. That is application of Biot-Savart's law. So that will be included. All the magnetic fields, no, we did mu naught I by 2r for circle, mu naught I by 4 pi r, then finite line and everything. That, okay? Before the Ampere circuital law.
Ma'am, can you just scroll it up? That second part answer.
Ma'am, shouldn't it be MP, then 2MD, then 4M alpha
Where?
in the third one, ma'am? Like root
Third
M.
one.
Yeah, it is root MP whole root, right? Then 2MP whole root again. Shouldn't be 2MD whole root.
This one. This part.
Which one are you showing, ma'am?
This. Are you talking about this part? This
No,
line
the below
or
one,
this?
right below.
First, second,
No, right below the third one. Yeah, the third one.
third one. Okay, this one. So yes, what is here? MP. See, 2 kinetic energy and magnetic field will get cancelled. So under root MP by charge will be left. This is fine.
Yeah, then it should be 2MD, right?
2 MD. 2 MP is there. See, 2 kinetic energy and magnetic field. These are getting cancelled. So under root MD by QD is left. Under root MD is what? 2MP because MD is
Okay,
2MP. Charge is
okay.
fine.
Right,
R
got it.
alpha will be root 2.
So we're writing
R,
MD in terms of MP.
yes.
Okay.
Just substituted terms of MP only. That's why this relation, mass of deuteron is twice of photon. Also learn those things. Samya was asking something. R alpha will be root 2. R alpha. Where, Samya? From where? Here.
Yes, ma'am. It can be root 2, right?
Root 2. This is 2. See, this is root 4 divided by 2. So root 4 is what? That's 2. So 2 divided by 2 is 1. Which one's it? Under root 2 MP? Okay, you were asking the same thing. Fine. Yes, it's under root 2 MP. See class, actually root 2 kinetic energy divided by magnetic field is same in all of these. So that has been cancelled. This only you were saying, Zaid. Zaid, are you asking something? All right, fine. Got it. Zaid, you have unmuted your mic by mistake, I think. Do practice this question after the class. And text me done once you have written.
Ma'am, can you explain the last part?
Yes, sure. This fourth one, Fahad?
Yes.
See. See, Fahad, regarding the actual logic, no, why I have written kinetic energy as QV, that we'll do in the second term only. Second term means your that dual nature of matter. There's a portion known as photoelectric effect. Rest of the student, yes, Zaid, Sahal, Samia, Abia, who all were there, Madiha, you people, Wafia, you people can leave. And if anyone wants to ask anything, you can stay, otherwise leave. Fine, class. Fahad, you listen. See, Fahad, here what is happening? Kinetic energy is basically charge multiplied by the potential. Fine. Now, this relation we know, we are aware of this relation. This is a standard formula. I think you must have studied in 11th also. Did you study structure of atom? Are you able to recall this cutoff potential, stopping potential when you did structure of atom? Even if not, then also I'm telling you kinetic energy is charge into potential. So we knew this formula, but now we have no idea about kinetic energy. If we just leave it in terms of kinetic energy, what will happen? If you leave this in terms of kinetic energy, this formula, you have no idea about kinetic energy now, whether kinetic energy is equal, unequal. In the previous part it was mentioned, but yahan pe you are not aware of it. So what did we do? We try to write it in such a way that either charge is included or mass is included or magnetic field. All the known quantities are included. And the best possible way to convert kinetic energy in terms of potential is this relation. So for now, for the time being, just learn this relation. This will be helpful if questions come in your half yearly or UT. Fine. Now we have substituted this QV in place of kinetic energy in this radius formula. Once we did it, see, root 2 potential is same. So V and this under root M, all these three quantities divided by V. These will be same and they get cancelled. What will be left? Under root Q M under root QM divided by Q. Only this much will be left. So I took all the ratios of it. In the last, this much was left. Fine, Fahad?
Yes, ma'am.
Yeah? Written or are you writing?
Written.
Fine. Then I'll stop here. All right. Okay, Allah Hafiz.